Very pleasant morning to respected dignitaries and members of faculty. It gives me immense pleasure to extend to you a very warm welcome on behalf of Vasreddy Venkatadri Institute of Technology, Guntur, Andhra Pradesh, who has clubbed all of us for the national level 1 week online faculty development program on electric vehicles, technological advancements and trends, organized by Department of Electrical and Electronics Engineering in collaboration with Institute of Engineers India, that is IEI local student chapter. I am Varshita from the Department of Electrical and Electronics Engineering, Vasreddy Venkatadri Institute of Technology. Once again, welcome all the participants to ninth session of this national level online FTP. Today's our chief guest and speaker is Dr. Praveen Mannam. Warm welcome, Praveen sir. Thank you for accepting our request to be in the part of this FDP. Before hand over this session to Praveen sir, let me introduce today's speaker. Dr. Praveen Mannam is currently working as an electrical engineering trainer for Ministry of Education, Kingdom of Bahrain, for their technical and vocational education. Apart from regular teaching and training, he also acted as a team member for curriculum and examinations from 2015 to 2016. He started career as a lecturer in Aurora Group of Engineering Colleges, Hyderabad in 2006 and continued for 2.5 years, that is June 2006 to November 2008. After his master's, he worked as an assistant professor in KKR and KSR Institute of Technology and Sciences, Guntur, Andhra Pradesh, for 3.5 years. That is from March 2011 to August 2014. He got ratified as a lecturer by JNTUH in 2007 and assistant professor by JNTUK in 2012. During his working time, he performed various roles apart from regular teaching like internal exam coordinator, department coordinator, student association coordinator, etc. He completed his PhD in electrical power systems with a focused research on electrical microgrids in December 2020. MTech from Bharat Institute of Engineering and Technology, Hyderabad in Feb 2011 and BTech from Dr. Samuel George Institute of Engineering and Technology in April 2006. He is a senior member in IEEE Institute of Electrical and Electronics Engineering, USA, associate member in IETE Institute of Engineers and Telecommunications Engineers, India, member in IAENG, International Association of Engineers, China. He is continuing his research through publications in reputed journals, national and international conferences. He holds one Australian patent grant and two Indian patent publications. He published a book chapter in Springer lecture notes. He is an author for Fundamentals of Electrical Engineering book published by SIPH publications in September 2022. He presented two guest lectures for KL deemed to be University Vijayawada and one expert lecture in International FDP conducted by Vidya Jyoti Institute of Technology, Hyderabad on 14 September 2022. He attended 10 plus short term training programs and workshops. It is my privilege to invite such a noble personality, our chief guest, Dr. Praveen Mannam, sir, to start the session.
Thank you so much for this introduction. Actually, I thought you will tell only little, but you read all the document. Thank you. Thank you so much.
Thank you, sir.
Can I share my screen, sir?
Yes, sir. Yes, sir.
Please confirm.
Yes, it is visible, sir, and your voice is audible.
Oh. Thanks for confirmation. Actually, sometimes I will ask whether it is working or not. Please let me know someone whether the slides moving or not, voice coming or not. Don't hesitate, please. Thank you.
Yes,
Good morning to one and all. I'm very happy to be here and thankful to the VVIT management, head of the department, and faculty members. Last but not least, Dr. Rambab Garu for contacting me about this program and giving us this opportunity. I'm very happy to be here. Once again, thank you so much. Um, Today, I'm going to present about electrical vehicles and microgrids. I know you are listening a lot more sessions from last 5 days. Excuse me. Can you mute yourself, please? Okay, thank you. From last 4 days, you are listening a lot of sessions about electrical vehicles. But today, I'm thinking it is a little bit different than electric vehicles, but it is having a lot of interaction with the grid system. That's why my topic is electric vehicles and microgrids. Here, after going inside, you will know what is the interconnection and how these two are going together in coming days. Let's start my session. Here, my content presentation is going like this. I'm going to give a small introduction about problem, cause, and possible solution. Even though the problem is very known problem, we are not focused in that. That's why we are not taking serious about the problem. So here I will tell you a small case study, how severe it is and why we need to focus on the problem and why we need to look for possible solutions, especially related to our engineering sector, electrical engineering. We are the major source for that problem. That's why I will give small information about that one. Later, we'll go for possible solution, how it is going to happen. Electric vehicles, this is the topic, and this is one of the solution for the problem. And another one, microgrids, later research scope, directions and all, summary, question answer sessions. This is the flow of the session. Please be here and don't hesitate. If you have any queries, please type your questions on the chat box or raise your hands anytime, no problem. Instead of a one-way session, I prefer to be a two-way, bi-directional. So instead of calm presentation, if you are interacting each other, it will go nice manner. So please, thank you. Here is the introduction. Have you noticed any recent climate changes, which I'm showing here? Few of them I'm showing here, which are the major we observed from last decade. This is air pollution. Generally, we are hearing in India. Delhi is facing a lot of air pollution. So that government is trying to solve that problem. And if you see Amazon forest, there is a forest fires happening frequently, and we don't know the possible reasons for this one. Floods, recently we have seen 2 to 3 years ago, Chennai, the floods are hit severely and lot of damage to the Chennai, Chennai city. And we have seen these are problems we have seen recently. These are the climate changes happening. Nobody is creating. These are due to the pollution. So these are ringing danger bell to us. Why? These are because of the global warming. So whatever the problems we have seen before in the slide, these are happening finally due to the global warming. What are the causes for this global warming? Generally, this is the known topic, but I'm focusing on this particular point to start our session and to connect our topics to this one. I'm giving small information about global warming and its major causes. One is rapid industrialization. As we know, day by day, the population is going to high levels. To satisfy the public needs, we need to advance in every sector. So one of the major sector is industrialization. This industrialization is producing a lot of pollution into the atmosphere. So this is one of the major cause. And agricultural practices. Everyone need food. To get the food, we need to practice the agriculture the techniques. So this is one of the another reason. And third one is transportation. We are moving all over the world from one point to another point by using different means of transport, maybe car or bus or aeroplane or train or some scooter or two-wheelers or four-wheelers, three-wheelers, whatever. We are using the available transportation method and reaching from one point to another point. So everyone have at least two-wheeler in India. So transportation is the another major cause for the global warming. Deforestation, everywhere we are doing this one. This is the another side. And resources extraction. The final one is energy demand. These are the few major causes I have focused here. I have mentioned here. Among these six related to our today's topic, I'm going to focus on only two, which are transportation and energy demand. These are the two topics I'm going to focus because today's our topic is electric vehicles and microgrids. These two topics are related to transportation and sorry, energy demand. So global warming happening because of many causes. Among them, I am focusing only transportation sector and energy sector. Please remember this point, focusing only these two. So the problem is global warming. I'm focusing electricity generation and transportation. It is a simple one statement how these are happening from last few years, from hundreds of years. This is happening by burning the fossil fuels. As you know, when you burn the fossil fuels, automatically it will release the greenhouse gases into the atmosphere and carbon dioxide emissions also. So that's why these two are the major reasons. How these are major reasons? Think. When you burn the fossil fuels like coal, gasoline, diesel, petrol, which releases carbon dioxide and greenhouse gases into the atmosphere. This is a small statement, but it is having a lot of information inside, which already we know, but not focused. That's why I have a small case study here. I will show you what is the problem to the public or livelihood when you fire these fossil fuels. I will tell you that case study after few slides. Please bear with me. I'm using some statistics to tell some information. If I say simply this is happening, that is happening, nobody will believe. We must give some proper results or we must show proper proof. That's why I have did small research and I have found a lot of information from many websites and many organizations. Some of them I have mentioned here, but in the every slide in the above the below the matter, I have given the reference link also. So if you want, you can go through that link and you can find a lot of information. I have given a small information. Since it is a 1 hour or 2 hour session, we cannot give complete pin-to-pin explanation. We will give a small information how it is going to connect the topic and how it is useful to choose the research topics. So please don't expect full-fledged elaborated information in a 1 hour, 1.5 hour session. So these are the statistics I have collected from 3 to 4 websites. One is all our topmost websites. You can go through. See the banner in UN Environment Program. Air pollution, which kills more than 7 million people every year. Think about 7 million. Almost in Indian scenario, Indian methodology, we can tell 70 lakh people every year are killed because of air pollution. So it is the biggest environmental health risk. So here we are going to focus on air pollution only. Air pollution because of electricity generation and transportation sectors. Global warming happening because of in many ways. but we are focusing on air pollution. That air pollution is happening due to many things, but we are focusing only two sectors. One is transportation, another one is electricity generation. How this is happening? Have a look. This is the carbon intensity of electricity in 2021 according to the source amber climate. See here, the brown color is the highest carbon emissions per equivalent of kilowatt electricity. If you see the top line, if you see carbon intensity of electricity 2021, under there below, carbon intensity is measured in grams of carbon dioxide equivalents emitted per kilowatt hour of electricity. Means for producing 1 kilowatt hour of electricity, we are burning fossil fuels. This burning of fossil fuels are producing, emitting greenhouse gases into the atmosphere and carbon dioxide also. See, for getting 1 kilowatt of electricity, we are burning coal and that coal is emitting 500 grams of carbon emissions into the atmosphere. 500 grams of carbon into the atmosphere. See the color of the 500 grams carbon emission, and same color you can see in India. So many countries in Asia are producing same like this. When you see air pollution, it will not stay in the same region. It will move to nearby countries also. So near to us, we have China, which is also producing high carbon emissions into the atmosphere. So our country is completely affecting a lot because it is a highly populated country. Recently, we have crossed China also, so we are the number one in population. So when this pollution is happening, this is going to affect the health of humans and they are going to die. So if you concentrate here, we are getting 500 grams of carbon emissions per 1 kilowatt of electricity. Think how much big is our power grid and how many gigawatts of electricity we are generating by using coal-based power plants. There, I will tell you those also later. This is the slide which will tell you the number of power plants, coal-based power plants worldwide as of July 2022. So means it is almost 8 months before. If you see, China is number one, which is having high number of coal power plants, and second place is India. So China and India have more coal-based power plants. After that, US. If you think US is far from the India and it will not affect us, it's okay. But if you think about the China, it is affecting India and India is affecting China because of producing the emissions into the atmosphere. So if you see the statistics here from the statista.com, this is the number of power plants graph, and on your right side if you see 71% of world total 71% of world total power plants are coal-based power plants, which are located only in Asian region. Asian region. Since India is a part of Asian country, it is a Asian continent, it is having lot of impact because of the pollution. So for this reason, we need to focus on the pollution control. How we are going to focus? Is it our individual responsibility or it is global responsibility? That we can see in coming slides. See, this is the small information. Every governments have some proposals to reduce the carbon emissions to by 2030. That's why here you can see the carbon emissions they are expecting to reduce to the very low level by 2030. The carbon emissions from the transport sector. Before I have shown you a carbon emission from electricity sector. In this electricity, we have seen India is under danger zone because high amount of carbon emissions are producing here. And if you compare with America, USA, this is behind lesser than Indian pollution. If you coming to the transport sector, the scenario is reverse. See, India is having less amount carbon emissions compared to USA, and see the USA is producing more carbon emissions into the atmosphere through the transport sector. So if you see somewhere the problem, the pollution is happening because of some reason. Here we are focusing only to the transport and electricity sector. If you observe the electricity sector, most of the Asian countries are producing high pollution into the atmosphere. If you see the transport sector, the America, US producing high amount of carbon emissions into the atmosphere. So if you may think why this much introduction is required for a small topic like that, that can be explained in one slide. I'll show you here. Example case study. Air pollution from coal-fired power plants. Please be patient to understand the small information here. If you understand the severity of this slide, automatically you may focus on this pollution concept. Otherwise, it is just like a regular concept to us. Air pollution from a coal-fired power plant. I'm telling you here only about the power generation by using coal. After burning the coal, we are producing the electricity, just like the Vijayawada Thermal Power Station, Dr. N.T. Narla Tatara Thermal Power Station. There are many thermal power stations in India. It is the small case study on a globe. According to the Union of Concerned Scientists, all the scientists, according to them, in an average year, a typical coal plant, which is 500 megawatts, generates the following amounts of air pollutions. See, 3.7 million tons of carbon dioxide, which is cause for global warming and climate change. 10,000 tons of sulfur oxide, which will cause acid rain and cause lung damage, heart diseases. See here, carbon dioxide is affecting. When you burn the coal, it is going to release so many greenhouse gases into the atmosphere. Those are highlighted here. One is carbon dioxide, which is changing the global warming and climate. Sulfur dioxide, which is cause for lung damage, heart diseases. Nitrogen oxide, it will affect the respiratory system and it will create the problems to the respiratory. Hydrocarbons, which are cause for smog formation. Carbon monoxide, which is cause for headaches, stress on people with heart disease. And mercury, see here a small statement, 1/17 of teaspoon of mercury deposited into 25 acres of lake can make the fish unsafe to eat. See, a small amount of mercury is mixed into the 25 acres pond. The fishes in that pond are not useful to eat. That much danger is happening because of the mercury. Next, arsenic, cancer out of cancer in 1 out of 100 people. Lead, cadmium, toxic heavy materials. These are going to affect the human life severely. So simply we will think we are burning the coal and we are getting the electricity. But in between, this much is happening in the air. When you do the research on the people who are living near to the thermal power stations, you can observe these health issues on them because of the very close to the power plants. When they are living very close, they may have some of the problems severely because of these emissions into the atmosphere. So this is a small scenario to understand the severity of the air pollution. When you cut out this power plant and this can be replaced with for renewable power plants, the problem is going to reduce to the some extent. So those are the our possible solutions. So here finally I would like to tell you over 40% pollution is generating due to the electricity generation by burning fossil fuels like coal, oil, gas. And the second thing, 24% due to the transportation. If you see, power generation and transportation both are using fossil fuels only. In generating stations, we are using coal, oil, gas, but in the transportation, we are using petrol, diesel, gasoline. All are fossil fuels. When you burn the fossil fuels, automatically it will release the greenhouse gases into the atmosphere. When greenhouse gases levels are increasing, the global warming is going high. When the global warming is going high, whatever the first slide I have shown you, we may see the natural disasters frequently, which is very danger to the life. So what is the solution? Finally, I'm going to tell you the global solution. I would like to focus on this one because if you think only for you, it will not affect much. It must be a global solution. What is the global solution? Every country must be a part of solution, but not be a part of pollution. See, it is the slogan every country needs to follow. The global initiation. I think many of us, since all our faculty members and are related to electrical department, they may heard about this one, Paris Agreement. This is the one of the global initiation which is going to fight about global warming. It is happened in Paris in 2015. This is the origin for the development of these greenhouse technologies. Before this 2015, the point is not that much focused. But after 2015, based on this agreement, goals and targets, this pollution is focused a lot. So this is the global initiation participated by 196 countries, means almost all the global countries, all the countries on a globe are participated in this agreement. Means they agreed that they will follow some policies to reduce the pollution so that the global warming will be controlled. This has happened in 2015 and they have some goals, Paris Agreement goals called as Paris Agreement goals. According to these goals, they will prepare some rules and regulations and they will ask the participation countries to follow and tell the results within 5 years for every 5 years. So they will give you 5 year cycle. In that 5 year cycle, every country needs to show their progress, how they did, what they did, and what are the results for reducing the global warming. This is the Paris Agreement and global initiation, their targets. See, finally, this, coming to the summary of the introduction. Sorry, I have presented 20 to 27 slides for the introduction only. Don't feel bored. Because of its severity only, I have taken this much time and this many slides. Summary of introduction. If you see the pollution, global warming is the point. The pollution, air pollution is the focused problem. And the causes are 40% carbon emissions due to the electricity generation. In this 40%, about 45% of pollution from the coal, about 35 from oil and 20% from the gas. See the transportation, 24% carbon emissions due to burning of fossil fuels, in which 3/4 from the road transport. 3/4 from the road transport. This is the highly focused area nowadays for introducing EVs. So these are the two origins for our coming topic. The possible solution for the electricity generation is through renewable sources. If you replace the fossil fuels with renewable sources, the pollution levels are going to low, very, very low. Similarly, in the transportation sector, if you replace the combustion engines with electric motors and the electric vehicles, then the carbon emissions are going to reduce so that the pollution levels are going to reduce. Finally, the global warming is under the control. So as a electrical related person, these two are the two contributions from our side to reduce the global warming. Generate the electricity by using the renewable sources and use the transportation which will produce zero emissions into the atmosphere. See, the first one possible solution, you may wonder or you may think these renewable energy sources are available from the day one when we see. But these are not focused before, only focusing from last few years only. And similarly, if you see the zero emission vehicles concept in which we are using electrical vehicles one, this electrical vehicles concept is not a new one. It is also a old one, but not focused till today. Means, as I told you, a global agreement. After this global agreement, which is called Paris Agreement, all these technologies are focused and giving boost up to develop them for reducing the pollution. Before that also, these technologies are available but not focused that much. So from last few years, we are observing many countries are changing their power scenario from conventional to non-conventional, and transportation from for this one combustion engines to electrical vehicles. See, the first one I am the first solution one we are considering is transportation. In the transportation, we are taking zero emission vehicles, not IC engines. IC engines use fossil fuels. When you burn the fossil fuel, we have seen the problem. So we need to replace these IC engines with electric motor. When you use electric motor, it needs electricity. When you use electricity, it will not produce any harmful gases into the atmosphere. So this is the concept here, the zero emission vehicles. It is a vehicle that does not emit or exhaust other pollutants from the onboard source of power. See, when you see the vehicle, it needs input. That input may be petrol or diesel or gasoline. When you burn this one and we are getting smoke into the atmosphere, that means we are polluting the environment. But if you see here, zero emission vehicle, it is a vehicle that does not emit exhaust gas or other pollutants from the onboard source of power. For that, I have a given small statement, zero well-to-wheel emissions. In broad array perspective, the electricity used to recharge the batteries must be generated from renewable or clean sources such as wind, solar, hydroelectric, or nuclear. Means here, if you see, zero emission vehicles means it is not only the point of vehicle, but how you are charging that vehicle, that is also considerable. Well to wheel means how you are charging the vehicle, that is also considered. Simply if you think I have electric car, I'm charging the battery, I'm using my car and my car is not polluting the environment, so I'm contributing a lot to the environment. Like if you think like that, that is wrong prospect. How you are charging your car, that is also need to be considered. The electricity you are getting from into your home or your office, if you are taking that power from the fossil fuel plants, that means your vehicle is not a zero emission vehicle. Note this point. If you charge your vehicle by using a power which is coming from the fossil fuel power plant, that means your vehicle is not a zero emission vehicle. When it is called zero emission vehicle, see, when you charge your car or battery by using clean sources from wind or solar or hydroelectric or nuclear power, means you are not producing any harmful gases even in the power station to charge your battery. That means from the generating station to charging point, your car is not producing, your vehicle is not producing any gases into the atmosphere, so that then only it is considered as zero emission vehicle. Of zero emission vehicles. Number one, animal powered. You know that one in olden days we have all this. I mean, there is no pollution because of this type of transportation and this type of power. The second one, human powered. We have the best example, bicycle. If you are using bicycle, there are no harmful gases. Then third one and the focused one is battery powered, which is the today's topic, electric vehicles. So this is the focused area from few years because of the focus on environment. We have these technologies before also, but not focused. From last few years, this is focused area. See what is going here. From last few days, I think many of the experts they have explained about advantages, disadvantages, type of charging stations, expectations, all these things. Here also I'm giving small information. Electric vehicles, the advantages are eco-friendly, means environmental friendly, low maintenance because of there are no much moving parts. The maintenance is very less and cost effective. It is in the point of charging only because when you charge a battery for 1 kilowatt, how much amount you are spending. If you compare same with fossil fuel, it is less. That's why it is cost effective. Less noise and smoother motion. You see the motor running smoothly. That means the combustion engines will move with high noise. If you compare with the electric, it is very low noise. So less noise and smoother motion. These all are known points to you. No need to explain much, I think so. And pollution also known point to you. No need to explain. But to know the severity of the pollution, I have explained that many slides. So don't think. Government support. If you see electric vehicles, we are getting a lot of government support. They are giving incentives to the manufacturing companies and the charging stations or and the buyers also some tax incentives. They are not going to charge much on the green energy vehicles. So this is the support from the government, and this will be running on renewable energy sources. Means if you have rooftop solar system on your home or on your building or complex, that power you can use to charge the battery of your vehicle. So it will run on the renewable energy sources, or some of the vehicles already have rooftop solar on the vehicle itself. That solar power is going to charge the battery and vehicle to move the vehicle. And if you see the disadvantage, high initial cost. This is the main point. Because of this, the people are taking time to buy the vehicles. And the second one is charging station limitations. If we can see the many petrol stations on roadside, but not on the charging stations. So charging stations limitation is the one of the major factor. If the infrastructure is available already, then public will come to buy electric vehicles so fast. So charging stations limitation is one of the drawback. High initial cost is the another drawback. Recharging takes time. See, when you go to the petrol station with the combustion engine vehicle, that will take only 2 to 3 minutes to fill your tank. But if you consider the electric vehicle, it will take more than half an hour to charge the battery, and this is the one of the main reason charging time. Limited options. As of now, this is in the starting stage. We have only limited options. We cannot have many options like IC engine vehicles. So limited options means maybe 2 or 3 only. Less driving range means this is the just like a how many kilometers we need to we can travel with the full charge of battery or half battery. This is the less in driving range. If you charge fully and if you reach your destination, there is no problem. If you charge fully and if you are unable to reach the destination, that is the big problem. That's why less driving range. If you need more range, you need to buy high power battery bank vehicles. So this is the another drawback. When you see the high power battery bank, automatically cost will be high. So these are the few drawbacks, and you can consider these as a research scopus, research focused areas. High initial cost. Why it is high initial cost? You can see electric vehicles are having lot of conversion technologies inside it to charge the battery. When you see the converters, inverters, batteries, all these, or expensive nowadays because the technology is developing now for the electric vehicles. So when you reduce the cost of this conversion, automatically the vehicle cost will reduce. And the charging time, batteries. If you see generally a small example of your mobile, for charging your mobile, we are taking almost the mobile is taking on 45 minutes to 1.5 hour based on the company. So for charging only your mobile battery, we are spending half an hour time to 45 minutes, 45 minutes time to 1.5 hour time. Think about a big battery, how much time it requires. So if we do the research on this charging time and the charging time, this is one of the major area for the research. Next, less driving range. The driving range must be improved to satisfy the all types of customer needs. The people who needs long distance travel, they also must be satisfied. So this is the another point. If you see nowadays lithium ion batteries are popular and the research is going on lithium ion batteries, but still the people are looking for very fast charging and within less time. So these are the advantages, disadvantages of electric vehicles. If you tell someone go and buy electric vehicle, nobody will buy simply. You have to think all these charging stations and the service stations and the charging recharge, sorry, driving point and all. See the electric vehicles and its market. Why I am telling all this is the research point of view. If you want to choose electric vehicles, how you need to think, is it going to fruitful in coming days or not? So the research is saying electric vehicles market is going to projected to reach 457 billion US dollars in 2023, means this year, and it is projected to 858 US billion dollars by 2027. See, it is almost double in within 4 years. So within 4 years, almost double means it is having high demand. When it is in high in demand, and we are doing our research in the same areas, we will get the opportunities easily. And the people who are looking to shift their vehicles, they can shift easily. The people who are wants to work in this particular area, they can do lot of research and they can do lot of work. After that they will get very high paid jobs. Nowadays in India we have Tata and Mahindra, they are producing electric vehicles and they are giving notifications for the EV market, but the people are not much to go there. That's why if you do research or if you work on electric vehicles, definitely it is a booming area within 4 5 years. See the market strategies worldwide. This is worldwide, and later I will tell you about Indian scenario. See, China is the most revenue from the China. Means China is producing more electrical vehicles than any other country in 2023. See here, global electricity demand by select vehicle type. Say we have electric vehicles on roads like cars, trucks, buses and all. In 2020, this is the energy demand 21,655 for the four wheeler, and by 2030 it needs 4,86,088 gigawatt hour. See, 21,000 in 2020 and 4,86,000 in 2030. Within the span of 10 years, how it is going to increase? It is the huge demand on electrical power generation. Where this vehicle needs to be charged, the vehicle needs to be connected to the electrical point. Where this point is connected, this point must be connected to the grid system. So this is all the demand in coming 5 to 7 years up to 2030. This much of energy is required to charge your electric vehicle. Who will give this much of electricity? If you take all this electricity from the coal-based power plant, again you are going to increase the pollution. So this all energy demand must be satisfied from the renewable energy sources. These are the charging points in US. They are having a Tesla over there. That's why they have a lot of charging points. This is a small information only. See the Indian market insights. India is the fifth largest automobile industry globally, and it is expected to become third by 2030. Since we have small information about the population, India is highly populated country, and if at least few 10% of Indian market adopts this EV technology, it is very huge demand, and they will increase the electrical sector, EV sector around the globe. So India is as of now, India is the fifth largest automobile industry, and it is expected by 2030 to third place. Means we are in advance, going to advanced position. And the drawback here is we are completely dependent on imports of crude oils. Almost 80% India is importing crude oils from other countries. This is the not acceptable point. Dependence on conventional energy sources is not suitable, as India is importing nearly 80% of crude oil requirements. Indian electric vehicle market size valued. See, in 2020, Indian electrical vehicle market is 100 million dollars. But if you see in 2021, it is 119.4, means within 1 year, 19.2 million US dollars change, means drastic change. That you can see here in the next point. Recorded strong EV growth in 2021, supported by government programs and policies. Means how it is happened. A lot of electric vehicle registrations are happened in 2021. Based on that, this data is generated, and this is going to grow $641 million by 2028. See, in 2021, it is $119 million. After 7 years, it is 641. See the growth, almost $500 million business is expecting within 5 to 6 years. So the EV market is having more demand in coming years, within 5 to 7 years only, not too much. But to be ready for that market, we must be skilled in this particular area, in the point of charging technologies or battery technologies, managements, converter technologies, inverter technologies, or grid point of view. These all are the challenges we have and needs to be worked out. Government Niti Aayog aims to achieve 70% of penetration of EVs in all types of 2030. So by 2030, if you consider 100 vehicles in the India, 70% government expecting EVs. This is the proposal they have. They are trying to target this achieve. See, around 0.52 million EVs were registered in last 3 years. In 2020, 21, 22, like these 3 years, around 0.52 million EVs were registered, means sold already in India. This is the small insights information about Indian market. This is collected from the Fortune Business Insights reference. These are the driving factors: reducing rising fuel prices, reducing EVs cost, government policies are the driving factors to boost up the EV technology, EV market. See here, Indian electric vehicle market share in 2021, almost 57%, 56.54% is four-wheelers. Four-wheelers. So if you focus your research or your concentration on four-wheelers research, you may have high chances to get into easily. And two-wheelers, three-wheelers are very less, because if you see India uses two-wheelers more, but all many countries are they are using four-wheelers. Whatever the knowledge you have, with that knowledge you can work anywhere in the globe. So you can move to any country. If you observe, the four-wheelers demand is more than two-wheeler and three-wheeler. In India also we are expecting 56% electric vehicles or four-wheelers, so that we need to work out more on four-wheelers. Already I have informed to you before in the slides, if you collect transportation pollution due to the transportation, sorry, so many slides. Here see, passenger cars are producing 41% pollution. In this circle, if you see 41% from the for passenger cars, means four wheelers, we have personalized cars, office cars, so whatever it may be, we are using cars. That cars are producing 41% pollution that can be addressed high, given first priority for the addressing the pollution. Later, medium and heavy trucks. So this is the focused area for EVs, passenger cars. Where is this one? Have you ever wondered how the way you travel around your city or around the world affects the planet? See, when we get some time, we will think we need to go someplace to see or some trip with the friends. This moment is polluting the planet when we are using IC engine vehicles. So, in order for transport to be sustainable, emission-free vehicles must be promoted, whether they are battery vehicles or green hydrogen fuel vehicles. For moving like this with our friends or family, if we have some solution from the country, we cannot use our personal vehicles. We will use the vehicles. So this is one of the small example. Austria is undergoing a revolution in sustainable mobility. This is just like a small point which already in Andhra Pradesh we have seen before, a cat card system. When you buy a cat card, you can travel in any RTC bus based on the price you are paying while buying the cat card. If you buy more amount, you can travel in AC buses and metro bus, luxury buses or super luxury buses, deluxe buses. If you are paying medium amount, you can travel in express buses, all express buses, anywhere in the state. From any place to any place, you will get some discount on the ticket. And if you pay very less, you can travel on the normal buses with less than regular price. Similar way, here Austria is introduced a single ticket that allows people to use any means of public transport in the country for European euros of 949 a year. Means a person, if he buy a ticket with 949 euros, he can travel in the Austria country by means of any transport, maybe train or bus or public transport, whichever is available. And government is going to replace all these vehicles with EVs, so that this person cannot think to use his own transport. He will choose only government transport, which is already green energy, green electrical vehicles, so that the pollution is going to reduce. This is the some of the idea, one of the idea of that country they are going to implement. So like this, we need some innovative ideas or technologies to reduce the pollution and to boost up the EV technology. As per IEA, International Energy Agency, global electric car stock expands to almost 350 million vehicles by 2030. See, in coming 7 years, the rapid growth we can see in the electric car market. It has depends upon the battery manufacturing and critical mineral supplies. Means if you provide more support to the manufacturers, then the growth will be high. if there is any limitations like policies or regulations or permissions or some lack of raw material supplies, then the growth will be less. So this is completely depends on country to country, but it is going expected by 2030 350 million vehicles on road. Among 2030, 60% of vehicles, 60%, if you take 100 vehicles in 2030, almost 60 vehicles are related to EVs. All these EVs, till now we have discussed about electric vehicles, which are the solution for reducing the pollution in the transportation sector. Whatever the electric vehicle you have, that electric vehicle requires a charging infrastructure. It may be car or scooter or bicycle or bus or anything, battery based system or electric vehicles, whatever you have. In the previous days, you may heard about different types of electric vehicles, battery electric vehicle, hybrid electric vehicle, plug-in type electric vehicle, all these, whatever it may be. If that is required to charge, it needs charging infrastructure. So this charging infrastructure must be provided in as many as possible for the convenience of customers to adopt this EV technology. So this charging infrastructure is the key factor in EV industry. Grids and EVs. From the grid perspective, EVs represents an increased load. So generally, if you think a small example in your home, for example, you have fridge, refrigerator, television. After few years or after 2 months or 1 month, based on the summer, if you want to buy a AC, that means you are going to increase the load in your home. When you increase the load, automatically you need more electricity from the government. When you need more electricity, you need to pay more bills. So this is the one by one chain cycle going. When you fix a air condition in your home, and if you switch on the air condition, that will draw the power from electrical grid. Similarly, if you think about neighbors, if you are staying in one apartment and in that apartment, if you have 20 flats and 20 flats have 30 air conditions and all are going to use in coming 2 to 3 months, government has to think electrical department need to produce electricity in coming 2 months. This is the projection. So in the similar way, if you think about electric vehicles, these vehicles need charging points and these charging points are coming from the electrical grid. The grid is going to overload. Simply, electrical vehicles are increasing load on the grid. From the grid perspective, how it is going to evolve? This is the main question many utilities are thinking about, because if the this is a primary question which needs to be addressed in a nice manner. Otherwise, the industry needs to going to affect severely, because if you see when you are driving a vehicle and it is stopped in between, you will suffer a lot. You don't know, maybe it may be even a small problem, fuse burning, fuse blown up. Then you don't know the problem, fuse is blown, but the vehicle is not moving, means we are facing big problem. So even the problem is very small, we need to understand it very well and provide the solution in a nice manner. So here the problem is have seen one solution for the pollution in the transportation sector, that is EV. When we are considered EV, it is benefit to the environment, but going to affect the power grid. Means one side the benefit is pollution less. Other side the drawback is it is going to put more load on the electrical grid. When EVs are going day by day to the high numbers, it means it is a burden to the grid. How it is going to impact the grid? See here. The growth of EVs and its charging stations has a positive impact on the environment. See, we are using EVs and it is not producing any pollutants. Means it is benefit to the environment and the economy of the countries also. But it can have detrimental effects on the power grid. What is that? We can see here. Impact of electric vehicles on power grid. See, there are positive impacts and negative impacts. The negative impacts are voltage instability, increased peak demand, power quality problems, increased power losses, transformer heating and overloading. These are the main drawbacks which are very bad to the system. We have already power grid. When we are connecting something to the power grid and that is going to introduce all these problems, that means they don't allow you to connect simply to the grid, means charging point. They will ask you, the grid people will ask you to solve all these problems before going to connect to the grid. So these are the key points we need to focus on our research or on our coming days to solve the problems. When you want to charge your electric vehicle, there are many options. From last few days, many faculty members explained fast charges and slow charges, AC charges and DC charges, level 1 charger, level 2 charger, level 3 charger. There are different terminologies they are using, but whatever may be the charger, it needs to connect the grid through charging station to the EV. When you connect this type of when you connect EV to the grid, it is going to affect the grid. How it is going to affect? Like this: voltage instability. When you put load or suddenly onto the system, huge amount, it will, voltage dips will happen and the instability of the voltage takes place. Increased peak demand. Suddenly, if there are hundreds of cars are putting charging, that means the load is increasing on the electrical grid, means peak demand is very high. Power quality problems. If since the electric vehicle contains motors, power electronic converters, batteries, these converters, rectifiers or inverters, AC to DC, DC to AC conversion takes place. This AC to conversion process will introduce hormones into the system. These hormones will affect the voltage and frequency of the system. Means automatically it is going to affect the quality of power in the grid. So when you introduce the EVs into the system, it is going to change the voltage, means voltage instability. It is increasing the load on the grid and it is increasing changing the quality of power. So the third one is fourth one is increased power losses. Since it is a converter technology, there are a lot of losses happening and those losses needs to be addressed in a nice manner. And transformer heating. See, here we are using converter technologies. In these converter technologies, there is a possibility of harmonics. When the harmonics are developed and these are introduced into the system, this is going to affect the distribution transformer on other power system components due to its overheating. When it is happened, the lifetime of these devices are going to reduce. Instead of 20 years, it will come to 10 years roughly. So see, these are the major problems when you connect EV to the grid. That's why the concept is impact of EV on electric grid. When you connect EV to the grid, the negative impact is voltage instability, increased peak demand, power quality problem, increased losses, transformer heating and overloading. These are the negative points which are the origin for research topics. You need to, if any research scholars are working on the voltage topic, they will know the real problem, what is happening when you connect EV to the charging station. And people who are working on power quality issues, they know this is a third problem. It's like this, based on the person interest, they can choose any of these points to as a research topic, so that in coming 4 5 years, as you we have seen the market growth, you have better opportunities in this sector. And see the positive impact. Till now I have we have seen negatives. Now see the positive impact. The positive impact is benefits of V2G technology. Here V2G technology means vehicle to grid. V means vehicle to grid. This is one of the technology, and it is the positive technology. What it is, I will tell you in the coming slide. Here there is another concept, V2X technology. V2X means in the X place you can fix anything, vehicle to vehicle or vehicle to grid or vehicle to home or vehicle to system, anything you can keep when you are aware of communication technologies, and by say taking care of the um, your internet safety. Security systems. Cyber security is the major issue to follow the V2X technology. Now there are a lot of research is going on security issues. So I think yesterday or before yesterday, one of the presenter, they may explain the cyber issues in the vehicle technology. So this is the small information, but it is very important slide. When you are thinking about EVs, think about this point also. When you are introducing EVs into the power system, you are charging. Power system means not the whole country. Your home also a part of power system. Your office also a part of power system. Wherever you are want to charge your vehicle, it needs to connect to the charging port, and the charging port needs to supply the electricity which is taken from the power grid. So when you are connecting EV to the grid, it is going to produce all these negative and one positive. This all already I have explained just now. Power quality, the harmonics have impact on distribution assets, which reduces their lifespan and also cause false tripping. Majorly transformers, power cables, relays, switch gears, metering equipment, capacitor, these all are going to affect when you introduce EVs into the system, because harmonics, these harmonics produce some uninterrupted signals. The signals will give all problems to this equipment. See how this is going to address. The concept is grid balancing. Objective of the grid balancing is to constantly balance the energy supply and demand. Means whatever the electricity generated, that must be consumed, or whatever the demand is there, that must be generated from the generating station. When these two are equal, always, that is called grid balancing system. Short run means for a short time, when utilities cannot balance their local grids, they must buy energy on the energy markets, an expensive proposition to meet the immediate demand and prevent outages. See, it is just like simply our need. For a while, if you need something and if that is not available readily, you need to buy that one with more money from other place. Same like that. In the if you experience a load center in Vijayawada, AP State Load Dispatch Center, they will tell you how the power market is going inside the load center. This inside the load center, they have interconnection SCADA system. In that SCADA system, they can see all the power stations which are connected in AP and India. In India, whatever the AP power requirement, Andhra Pradesh power requirement they have, they will choose according. They will satisfy the load by choosing the proper plant which will produce electricity for less price. So this is all happening. If they don't have sufficient, they need to buy from a other country which is already interconnected into the Indian power grid or some regional grid. If in southern grid, we are in southern grid. In the southern grid, if generation is not available, then we need to ask the central grid, I need electricity and for the best price, so that they will tell you whichever is closest to you and for less price. Then we can buy from there. But if the need is urgent, you need to pay more also. That is the condition. Balancing the grid for long term before it is short term. Before for short term, for balancing the grid, you need to spend more money for sometimes. For long run, to balance the grid, significant capex, capital expenditure means whatever may be the future. If you prepared a system already for a 10 years expectation, you can satisfy the requirements. For example, you have designed a system for 20 years, but now there is no that much load. But you have a plan for 20 years. Based on the 20 years plan, you have a generation, you have a transmission, distribution, and the charging points. Say you have 100 charging stations and only 10 electric vehicles available in your locality. So these 10 charging vehicles cannot come to this 100 charging points. They will use only 10 charging stations to charge their battery. But remaining 90 is for future, means you need to put more money in capital expenditure for developing this plan for 20 years. After 5 years, if the electric vehicles are increased to 50, at that time no need to bother. Already you have 100 charging stations, remaining 50 is the spare for another coming years. So this is the capital expenditure for long term, and before one is the short term. How can EV charging service providers help achieve grid balancing? See here, if you observe grid system, in the grid system there are different stages: generation, transmission, distribution, and local distribution law. Just like our petrol stations, there is local petrol stations, how they are going to operate their petrol station to satisfy the customer needs. Like that here, how this EV charging service provider are going to help the balancing grid. Ensuring grid balance is concerned within the EV industry, the demand for EV charging has put on excess burden on the grid. As I told you, when we are thinking about EV, it is burden to the grid. But how it is going to achieve, addressed by the EV charging providers. To avoid extra investments in the upgrades in the power infrastructure, these EV charging providers are taking alternative approaches. Instead of putting more money, they are thinking alternatively. How it is happening, see here. The concept is optimization of energy utilization and achieve grid balance. This is the concept. They need to get the energy from grid and they need to charge the vehicle whenever they need. This is the optimization technology they need to follow. How these are going to happen? By see, there are following three different methods. One is managing EVs as a distributed energy source. Means whatever the electric vehicle coming to them, they are using that vehicle as a distributed energy source, because EV have battery, means we can store the energy in that battery. So battery is one of the distributed energy source. So for a while, these service providers using these EVs as a distributed energy source to balance the grid. This is not happen with his own interest. It must be with the acceptance of the EV owner. If EV owner agrees, then only it is possible. This is the first one I will explain in next slide. Second was smart energy management. How they are going to manage to balance the grid. And third one, integrating renewables. So simply here, the point is there are booming industry for EV electric vehicles. When you think about electric vehicles, we need charging stations. And these electric vehicles are burdened to the power grid. These charging stations, how they are going to balance the grid and EV charging. by using three different ways. Management of EVs as distributed energy sources. The first one is management of EVs as distributed energy source. See here, as a vehicles are parked most of the day, means for example, if you take Vasireddy Venkatadri College, morning time we will reach the college within 15 to 20 minutes or half an hour from Guntur to college or Vijayawada to college or from somewhere to college. It will take hardly half an hour if you are using electric vehicle or any vehicle like a four-wheeler or two-wheeler. And if your vehicle is a electric vehicle, after that half an hour travel, what you will do, you will park your vehicle somewhere in the campus. After that, from that time to till evening, almost 7 to 8 hours, the vehicle is in stable condition and it is having a battery fully charged. I think almost 80%, 90% charge with charging. That can be used as a grid balancing point for peak loads. See, a vehicle is parked most of the day. Using EVs as a distributed energy source, batteries on wheels, can minimize the strain on grid to achieve grid balancing with grid to vehicle technology. See here, you may think, what is the use if I give my battery power to the grid? Here there is a point, you will get money for that giving electricity to the grid, just like a smart meter, bidirectional meter. When you have your home with rooftop solar and you are using rooftop solar in your home and selling excess power to the grid, to the distribution system, they will give money to you. In the similar way, a vehicle which is charged fully during the night time and used for 20 minutes to 30 minutes to reach the college, and it is in the standby position in the campus, remaining the battery power can be used by the electrical grid through the distributor, this charging provider, by providing some amount to you. So simply you are using your battery for short time and remaining time you are giving permission to the charging provider to use your battery power for grid balancing. For that he will pay some amount to you. So this is the vehicle to grid technology. We are giving power from vehicle to grid. When this is happening, there is a chances of earning money with your own vehicle, like solar power. You are earning money with solar power. Same way, you are earning money by using your vehicle by contributing power to the grid. So this is one of the technique they are following. For example, if you take any big company or big campus, like for example, 1000 employees campus or 2000 employees campus, in which the majority of them have 500, for say 500 vehicles. If 500 vehicles are parked over there for 7 hours, 8 hours, these 500 vehicles power can be connected to the grid during the peak time and they will get amount accordingly. And when they are ready to leave, they can inform this charging provider so that they will charge the battery before half an hour or 1 hour. Then your vehicle is ready to go back to your home. This is the technology they are using. Then second one is smart energy management. They are managing the energy between the consumer and supplier by using this energy management algorithms. So this is you can see in optimization techniques. They are following optimization techniques to manage the energy between demand and generation. Integrating renewable energy sources. So this is the point for next topic, which is the origin for the next topic. Integrating renewables is the third way to satisfy the EVs. How these EVs are going to supply the energy. Wind and solar are the most common renewable energy sources supplying energy to the EV charging sector. So as I told you, if you have rooftop solar system that is used to your home purpose, the excess energy you can use for charging the EV. Okay, So this is one of the technology. See, this till now I have explained to you, we have pollution that is coming from transportation and electricity generation. In the transportation, to reduce the pollution, we are going to EVs. When you are using EVs, this is going to put burden on the grid sector, electrical grid. This is going to create problems to the grid. And these problems are solved to some extent by the charging providers. Remaining are solved by the manufacturers who are designing converters, inverters, batteries. They are going to solve some problems. So this is the one of the solution for reducing the pollution by means of transport. Coming to the next topic, microgrids. When you see the third point, integrating renewable energy sources to balance the grid, the same point is urgent for the microgrid. Microgrid concept came into existence with the use of distributed renewable energy sources like wind, solar, geothermal, micro hydro turbines. So when you are using renewable energy sources, distributed renewable energy sources, there is a concept called microgrids. No need to consider the whole grid. Here you can form your own grid. For example, if Vvit wants to form a microgrid, they can form microgrid by installing solar system on their location and by installing wind system in the possible high wind location, and one diesel generator set and one battery system. So finally, for example, if Vvit wants to operate their electrical system by own, they can make their own solar system, they can make their own wind system, they can use their diesel generator system, they can use their battery system. These four systems are going to interconnect and operate as a grid for Vvit. That is called Vvit grid, maybe you can call it as. It is called microgrid simply. So when you have 3 to 4 technologies in your premises, you can integrate them to satisfy your college loads in the laboratories, offices, workshops, anywhere. Whatever the load you want to operate, that load must be supplied by using any of the 4 technologies we have. 4 generating systems we have: solar, wind, diesel generator, or the battery system. Morning time we have solar, so take the energy from the solar system and satisfy all the loads in the college. If it is not sufficient, add some diesel if you want, so that your diesel cost will be reduced but your requirements will be satisfied. If there is a shortage of solar and wind, you can use battery, which is stored during the daytime, energy stored in the daytime, and the generator to satisfy your requirement. So by operating these four energy sources within your college, you can satisfy your load. Here, for doing this, we need a lot of analysis and lot of skills for designing the system. 4 generating stations, 4 sources: battery system, diesel system, solar system, hydro system. Sorry, this one, wind system. These 4 systems must be designed properly, and the loads may be electrical load, electrical workshop, or electrical laboratories, electronic laboratories, mechanical laboratories. All these laboratories, you can calculate the load and you can calculate the generation. If these two are going to satisfy, you can connect it easily. So this is the small concept we can understand within our premises. Microgrids are coming to the existence when distributed renewable energy sources are coming into the existence. Here, no need to go anywhere for the solar, no need to go anywhere for the wind. These are available in your location, so that you can use those two by simply installing the solar panels and windmills. You can bring the batteries to your location. You can bring diesel generator to your location. No need to ask central government to send electricity from central power station to Vvit. You can put your own system in your own premises and you can operate independently without asking anyone. If you want to connect your system to the grid, then only you need to ask the people who are operating the grid. If they agree, then only you will get the permission to connect. So this is the concept when renewable energy sources are existing in the system. Here, microgrid concept is not a old concept. It is the it is not the new concept. It is a very old concept. Small definitions for small information about grid terminology: grid, conventional grid, microgrid, smart grid. Simply, I will tell you. Here we are expecting grid transition from conventional grid to smart grid. The green color is smart grid and the blue color is conventional grid. Here the production is large power plants in the yesterday's power plant. Now in tomorrow we are expecting many small power producers. Here we are producing, say for example, 100 megawatts of power. That 100 megawatts of power can be generated by using 3 power plants here, and same 100 megawatts produced here, 1, 2, 3, 4, 5, 6, 7, many 10 plants you can use here. So in coming days, more small power plants are coming into the picture. That is going to change the scenario. Market, transmission, distribution, consumers, all are going to change. Simply, the grid is transiting its changing its face from conventional to smart, but it will happen through the microgrid only. After converting this grid into small grid and implementing advanced technologies into this microgrid, we will reach the smart grid. So simply, smart grid means it is an electricity supply network that uses digital communication technologies. So microgrid, we are splitting the grid into small parts, and in this microgrid we are using digital technologies so that it is called a smart grid. Simply, the grid transition will happen through the microgrid concept only. Is microgrid new technology? How and when microgrid spotlighted? Why microgrids gaining popularity? These are the small few questions we can ask self to understand easily. It's a no. Ultimately, the answer is no. Origin of grid concept, it is came in the year of 1888. See, this is a power station developed by the Edison in the year of 1882 for a small location called Manhattan in the New York City, USA. Here, Thomas Alva Edison, he created his power plant on his own and generated electricity, and this electricity is connected to the consumers. See the highlights of the project. The first central power plant, it began producing electricity on 4th September in 1882. In 80s only we have this type of grid. Means microgrid is very old concept, but it is not popular before. Nowadays it is more popular. Initially for 85 customers and 400 lamps only. See the power plant, the area is 15 by 30 meters. Means 450 meter square area they have used for installing the jumbo generators, turbines to rotate the generator and to produce the electricity. That electricity is only sufficient for 85 customers for their lamps, 400 lamps. So this is not a microgrid concept, is not a new concept. It is very old concept, but more popular from few years only. See here small information 82. He generated generation at that time on his own. There are no regulations. There are no conditions. He can generate how much he want. He can do the transmission and connect to the load. Spotlights on microgrid. How and when microgrids are spotlighted? Generally, we will ask what is the reason, why it is came like that. So microgrid spotlight. For understanding this, let's have a small information, a small story. In the New York City, they lost power for few years, for few weeks. At that time, customers notice, means neighbors notice, not everyone lost power. In northeastern part of US, including When if you see the American state, America, there storms are common. Superstorm Sandy, called Sandy, hit United States in 2012. In 2012 means nearly 10 years ago. At that time, there is a power shutdown for few weeks. During that time, customers means neighbors, they have noticed few people have electricity, but few people don't have. They have they started thinking about that one, how it is happened. Only the thing is, it's the microgrid concept. Lights were on in some buildings in New York, New Jersey, and because they had microgrids. Means in their home they have battery backup. When they have electricity, they stored their electricity in the battery and they use when they don't have power. Means during this sandstorm, they have their solar system. They have their diesel generator system. So in this New York City, when sandstorm happened, superstorm happened called Sandy, some of the areas are not having power. But in that particular area, not all the customers are suffered. Many customers suffered, but few customers they have electricity backup by the means of their solar system, by the means of their battery system, by the means of their diesel system, diesel generator, whatever it may be. Some of them are have electrical supply. So the later, based on this observation, the politicians in that area, they have noticed many customers are suffering, few customers are not suffering. What is this reason? What is this? They have understood that one and they formed some policies to develop this microgrid concept. So from 2012 onwards, this is started highlighting. Before also there are, but this is the main reason to focus on microgrids. Ultimately, these are popular because of their modularity and flexibility. This is the general definition, standard definitions from the IEEE. You can see because of lack of time, I am rushing here. Microgrids briefly, simply, fundamentally not different from wide area grids. It is similar to conventional grid, but only the size matters. And the second thing, in these microgrids, we are using only renewable energy sources, not the fossil fuel plants. Fossil fuels are almost negligible. Means simply diesel generators are also negligible. They will be given least priority. Even they are a part of system, they will be given least priority after solar, after wind, after battery power. They have given least priority. So when microgrids, if you consider, it is a small size grid. There is no difference. And the second thing is the type of source. Only these two are the main differences between microgrid and the conventional grid. In microgrid, the size is less and the sources are renewable energy sources. But in the conventional grid, the size is big and they can use renewable, non-renewable, any type of sources. It is a small scale power supply network that is designed to provide power for small community. It enables local power generation for local needs, means whatever the locally available that can be supplied to the local loads. It comprises of various small power generating sources that makes it highly flexible and efficient, means you can use if you want or if you don't want you can shut it down. It is connected to both the local generating units and the utility grid, thus preventing power outages. Means when you have power problem in the main grid, it will not affect your grid. If simply you can disconnect from the main grid and based on the availability of resources in your grid, you can satisfy your loads. Excess power can be sold to the utility grid, just like or solar power. If you have excess power in your home, you can send back to the grid system so that you will be benefited. Size of the microgrid may range from housing estate to municipal regions. So you can change if you have money, you can install small microgrid in your home also, like putting the solar panels on your rooftop and battery system in your home and connection from the main grid. If you want, you can put a small micro wind turbine on your roof so that micro turbine solar system, battery, and the main grid. These all are four interconnected together to satisfy the load in your home. When you have problem with the main grid, you can disconnect from the main grid and you can operate your own grid, which is interconnected with battery, wind, and solar. If you have excess power, you can sell to the main grid. Best example, smaller island grids, individual systems of private utilities grids, community grids. So this small information. You can see here types of microgrids, standalone microgrids, grid connected microgrid. There are two types of microgrids. One is standalone, means there is no connection between the microgrid and the main grid. It is operating alone. The second one is grid connected microgrid, means we have microgrid and we have main grid. In between these two, we have a switch. When you need, you can switch on the power, means we can connect to the main grid. When you don't want, you can disconnect from the main grid. So you have possibility to connect or not connect, means when you need more power, you can take from the grid. When you have excess power, you can sell to the main grid. But in the standalone system, you don't have that system. If you have excess power, you can store it into the battery. If you have less power, there is no solution. You need to shut off the some loads which are not primary, not for prioritized. For example, if you see here, we have solar system, we have wind system, we have battery and rooftop solars on here, all this system. When we have sufficient generation that can be supplied through the central controller to the hospitals, houses, commercial complexes, EVs and all. When you don't have excess power to satisfy all these loads, you can shut down the unprioritized loads. For example, if these houses are not important, you can disconnect this one so that the load will be raised, remaining load will be satisfied with the available generation. But here, no need to worry. Even your shortage of generation in the your premises that can be satisfied by taking the energy from the main grid. So these are the two types of microgrids, and there are different types of operating modes we have. This is standalone microgrid. Simply think about island microgrid. If you are in island and there are some houses there, how those houses requirement will be satisfied. That is a standalone microgrid. See, they can install a small battery system, solar system, wind system. Interconnecting these three can use to satisfy the needs of those consumers. Okay, so this is the small information standalone microgrid. You can understand easily. It will operate independently. No connection to the main grid. If generation is more, they can store it into the battery. If generation is less, they can cut off some loads which are not prioritized. This is the system, operation in standalone. No need to experience microgrid on island. You can experience in your home or your company or in your college, wherever you are, if they have. Second one is grid connected type microgrid. Grid connected type means we have microgrid that is having a connection to the main grid. Just like business industries, they have their own power backup by using the solar system, solar installation, solar panels or windmills or the batteries or the diesel generator sets. Just like a VVIT, if you take in the VVIT, you may have diesel generator set. When there is a power cut, you can switch on the diesel generator set to satisfy the primary loads which are very important. But when your power is there, no need to switch on the diesel generator. You can switch off the diesel generator and you can take the electricity from the main grid. So that universities, institutions, hospitals, these all are comes under the grid connect type microgrid. See the operating modes of microgrids: off grid, on grid. Take off grid mode means we have a conventional grid and main grid, but the interconnecting switch is in off mode, means the microgrid is not connected to the main grid. That means it is similar to the standalone microgrid like before this one, like this one, type 1. So In second type, grid connected mode, there are two type of operations. One is off grid mode. It is similar to the standalone mode. See here in feeder A, we have generation and load, two loads. Feeder B, we have generation and loads. In feeder C, we have two generations and two loads. Okay. But if you see here, there is a static switch. This static switch is between ABC feeders and feeder D. When this grid is not connected, the static switch will be open. Means all this feeder D is supplying from the main grid only. The feeder ABC generation is not going to supply feeder D. So simply it is not prioritized load. The feeder A, B, C, these have loads and these have generation. The generation available here, it is used to satisfy the load feeder A and B, C. These are interchanging their generation to satisfy their loads only, but not supplying to the D. So simply off grid means the microgrid is not connected to the main grid, means standalone microgrid. On grid means we have the connection between main grid and the microgrid through the point of common coupling. It is called as point of common coupling, which will connect the main grid to the microgrid. Here the static switch is also closed. Here all the feeders are satisfied by means of main power source or from the local available generation. There are different types of microgrids. You can see later. I'm going to rush by benefits, advantage, disadvantage. You can understand easily. Because of lack of time, I'm moving because there is one more important topic is there. Advantage, disadvantage. Easily you can understand. This is the main concept. It came into the picture because of renewable energy sources. This means it will reduce the greenhouse gases. Okay. And the second thing, reduce transmission and distribution losses. Because of local availability of sources, transmission no need, only distribution. In this distribution, this is very short distance, so the losses are very less and the efficiency is more. So all like this, like that, we have more benefits. That's why microgrids are more popular nowadays. Along with advantage, there are some disadvantages also. The quality of the power is not good. Why? Because these are completely depends upon renewable energy sources, means solar and wind, which are uncertain in nature. We cannot predict next minute what will happen. If clouds are passing through, at that time the solar power generation will reduce instantly. So that this is the big problem in the power balancing. Requires battery banks. Means when the electricity is more, you can store that one in the battery system. For that you need battery banks, which is highly expensive. Difficulty in resynchronization. When we are connected to the main grid, there is a problem of resynchronization. Whenever you want to connect or disconnect, it is not that much easy. So there is a resynchronization issue. Issues net metering. Here, when you are connected to the main grid, how much power you are taking and how much power you are giving to the main grid, that can be calculated. Based on that, the bill will be generated. So the net metering is a big obstacle because it is completely not yet implemented. It is under some research stage and some places it is testing stage. Some places they are operating. So it is completely not at advanced level. Microgrid protection. It is the big topic when there is a sudden change in the power generation and there is a load. At that time, there is a possibility of failure of the grid. So we need protection. Ensure standards. Standards are very important for any development. So standards are need to develop here. Technical, these are the drawbacks. Regulatory policies, lack of energy policy, regulatory framework. These microgrids are more popular in European countries, but not in India. But nowadays, microgrids are coming into the Indian region also. So they are doing some research and some universities and institutions are working on this. So in the future, in 5 to 10 years, we are going to see microgrids also because we need to charge the EV. So research scopes, we can see the dynamic nature we need to understand. The power electronic converters are very important in microgrids and electric vehicles. Power electronics plays major role. In microgrid concept, I am going to explain. This is the dynamic nature of solar and wind, so we cannot predict what will happen in next minute. That's why we need more analysis on this. Microgrid industry drivers, continuous power supply. Even there is a power cut from the main grid, we can supply locally by available generation. Environmental objects like simply benefits, advantage of microgrid or industry drivers. This is the in market of the microgrid in coming years. By 2027, by 2027 means after 4 years, it will reach $49.2 billion US dollars. Now it is 2021. As per 2021, it is 26 US billion dollars. Within 6 years, it is going to reach double. This means the microgrid market is also one of the booming sector. You can invest or you can work on microgrids, or you can develop your skills in the microgrid sector. You can do the research in the microgrid sector because it is the booming sector along with EV. You can choose EV or microgrid because both are interlinked to each other. Research trends, it's already I told you, need to investigate full-scale development, field demonstration, experimental performance, evaluation of frequency and voltage under various operating modes. Here the frequency and voltage are very important to make the system balanced. So we need to analyze the voltage and frequency for certain conditions like shadow conditions or non-shadow conditions or bird dropping conditions or some damage of one panel condition like that. We need to do a lot of research how the voltage and frequency are changing under various conditions. Transition between grid connected mode and islanded mode interactions phenomena means the resynchronization issue we need to investigate. These are the research trends briefly. Cyber security. Maybe you may understand this one in the EV technology. Yesterday, I think before yesterday, Madam explained how important is cyber security. In the same way, in microgrid concept also, we need cyber security, which must be addressed in a nice manner. Autonomous operation, regulatory barriers, all these areas are need advancement. So we need research on this. The power electronics and their importance. See, if you see microgrids, there are two types: AC grids, AC microgrids, DC microgrids. In this AC or DC, based on the availability of generation, we need to convert from one form to another form. For conversion, you need converters. Those converters are power electronic converters. So when you are looking here, the power electronics are playing a vital role in EV industry and in microgrid industry. So power electronics are the very key primary technologies which needs to do lot of which needs to have lot of demand in these two sectors. So how your converter is going to convert from one form to another form as per the requirement. If it is working smoothly, then it is a successful converter. If it is not working, failure. So power electronic converters are very important in DC microgrids, AC microgrids, CV technologies. In EV technology, you need a converter to charge the battery. In the microgrid technology, you need a converter to convert AC to DC and DC to AC. Generally, if you see solar panels produce DC power. But this DC power is not to the our standard value. That must be converted to another DC value and connected to the DC bus. Here, if you see wind turbine, it will produce the AC, and this AC must be converted to DC and it is connected to the grid. Next, if you see the batteries are DC and need to convert to DC to the, and later this DC bus is connected to the load. Similarly, on AC bus side, if you see utility grid, you have AC power, it is connected to AC bus. And if you see here electric vehicle, this electric vehicle have electrical battery. This battery have DC power, and this DC power is needs to convert to the AC, then only need possibility to convert to AC bus. So this is AC microgrid. In this AC microgrid, DC powers are converting to AC by using the conversion. So the power electronic converters are the key role players in the grid technology and EV technology. So small information about a few slides about the technology. And here the coming to the final one, last very important one. I'm sorry, I'm very late. Technologies for research. Here there are a lot of technologies available for doing the research about microgrids. There is one of the technologies, OPLRT technology, which is designed particularly for microgrid. This OPLRT is one of the manufacturer and developer of this test bench. This test bench is used to analyze the microgrid with under various conditions. The second one is Typhoon Hill microgrid test bed. This is the another one to analyze the microgrid completely with all types of analysis. The third one is Homer Pro. This is a software package. You can use it and you can learn it to analyze the microgrid. And the last one, very known one, is MATLAB. You can use MATLAB for analyzing microgrids. So these are the four types of technologies available for analysis of microgrids under various conditions, fault conditions, mode generation, load analysis, all these conditions you can analyze by using any of the technologies here. But here, if you see the first two, OPLRT and Typhoon, these are hardware based. HIL, hardware in loop. Here also see hardware in loop means in the real time, whatever you have, the solar power generation, wind power generation, battery system, all the are coming with some cables. Those cables are connected here and you can do the analysis by using your algorithms or your optimization techniques and you can see the results here. And these are the software based technologies, MATLAB and Homer Pro. See the first one, OPLRT. This is the technology from 20 years. They have did a lot of research and they have developed a power hardware in the loop test bench. This is the hardware kit, less just like a control panel. For looking in physical view, it is looking like a control panel. Power hardware in loop test bench. It is OPLRT people they are calling as test bench, but Typhoon people they are calling as test bed. Test bench, test bed, but the concept is same. They want to analyze the microgrid. So OPLRT they have did a lot of work for a period of 20 years and they have developed a power hardware in the loop test bench. Here you can use test bench for ideal any type of microgrid application research by allowing users to have hands-on experience by testing real-time components in various operating conditions. So you can test your microgrid whatever the generation you have, solar, wind, generator, battery, whatever you have, you can design, you can use connect that one to the SOPLRT test bench and you can analyze how the results are changing for certain conditions. See, examples in India, OPLRT in IIT Kanpur, they have this technology they are using in their power system laboratory. IIT Gandhinagar, they are also having this OPLRT technology. They are using their research laboratories for microgrid analysis. And the second one, next one is Typhoon. This is also same like OPLRT, but as you know, manufacturer, even they are doing the same work, they will tell differently. So they are saying their technologies are best than other. We have two, Typhoon and OPLRT. Both are doing microgrid analysis. You can use anyone. Typhoon Hill microgrid test bed. It is also like a control panel. You can connect all the available resources and loads to the your control panel, this test bed, and this test bed will operate, analyze your system and will show the results in the screen and which are very useful to analyze the system performance. Here there is one benefit in Typhoon. They are having academy called Typhoon Hill Academy, in which they are giving training for the people who are interested to learn their Typhoon technology. You can go and register simply and learn from them and get it certified by the Typhoon Hill Academy. Just like Java certifications, Oracle certification, like PLC certification. Here, the Typhoon Hill Academy, they are providing a certification for their technology. Just I have given a small link here, reference link hill.academy. They are offering some courses how to use this microgrid test bed and how to become an expert in this technology. They are offering some courses. simply register. It is valid for 21 days. So 15, it is free. You can learn here and you can be expert in that. After the exam, you can get certified by the Hill Academy, which is very useful for the research laboratories who they are using this Typhoon Hill test bed. So simply, if you are certified by the Typhoon Hill Academy, you are having lot of chances to get recruited in the R&D centers where Typhoon test beds are using. And the next one, Homer Pro. This is a software. You can design your own system by selecting the data, by giving how many generators you have, which type of generation you have, how many loads you have, which type of loads you have. All you can specify. You can select the region where you are, where you want to implement the system. Based on that, it will collect the data from the NASA. That NASA data, the weather forecasting, wind, sun, solar irradiance, all will be collected from NASA, and that data will be used to analyze your system, how much electricity is going to produce, how the load is going to satisfy, what are the problems, what are the how the waveforms are going to change. All you can see here in this software. Here it is also providing a free trial for 21 days. You can download this one and you can do the practice. After 21 days, if you are expert in that, you can use easily. It is a very a convenient system to analyze your microgrid, to design and analyze your microgrid without any hardware devices. Before we have seen hardware devices, now it is a software. You can design a system in your computer. That too, these people are providing software for free for 21 days. So install the software, design your own system with all the loads, maybe load as a EV, incorporate 4 or 5 UEVs, one truck, one car, one bus, like one home, one laboratory like that, and design all the system, run it, you will get the results. As we know, the famous one, MATLAB. No need to explain about the MATLAB. Everyone knows. You can analyze the microgrid by design the microgrid by using MATLAB also. So this is the small information. And at last, finally, summary. Sorry, I'm continuously taking more time. Problem I have discussed global warming, in which I have focused air pollution due to carbon emissions and greenhouse gases. Okay, so the problem is global warming, and this global warming addressed areas due to electricity generation and transportation. By using electricity generation and transportation, we are polluting the environment. These two problems are addressed here. The solution is net zero emission vehicles. Means we cannot the vehicle which will not produce any emissions into the atmosphere. Whatever the zero emission vehicle, that is EVs. These EVs require charging, which must be charged from the renewable power generation. When renewables are coming into the picture, then microgrids is the point we need to start. For analyzing these microgrids, we have 4 technologies I have mentioned. Those are mentioned here. So in the whole summary, before 94 slides, all are I have concluded in this summary. So this is my presentation. Thank you so much for your patience listening. I don't know how much you understand. Thanks a lot for all this opportunity.
Thank you very much, sir.
Sorry, sir, took more time.
No issue, sir.
Thank you very much, sir, for your valuable session on behalf of Department of Ripley and Vvit.
Thank you so much. Thank you for the opportunity.
Dear participants, if you have any discussion to discuss with the speaker, please ask, sir. The next session will start at 1:30 p.m. Thank you, sir.
Thank you so much.
Let us end the session.